Hello everybody and welcome back. So in this next lesson we're going to be tackling classes. Now this gets really fun and it kind of builds upon a lot of everything that we've learned up till now, but it can get a little bit complicated. So don't worry if you feel a little bit confused about this lesson. This is the type of thing where you might have to come and revisit it later on, or maybe even just watch it a few times in a row and then it'll start making sense. We'll obviously try and do our best to make sure that we understand it straight away, but this is the type of thing that some people, it takes a little while to sink in properly. Now I'm going to start because I've already discussed an example before where we were talking about a human and a cup as being two different examples of a class, and then where each cup is an instance of that one class. So I'm going to kind of go back to that same example. So we're going to build something really fun here. I'm sure you guys will enjoy this lesson. So what is a class? What are we talking about when we say a class? So remember, a class is a type of object in Python. So, like everything else in Python, it is treated as an object. It has its own functions built inside of it, and it has its own variables. Now, those variables inside of a class are called properties, and the functions in a class are called methods. Okay, so if you come across those terms, you know what they're talking about. Now, really, a class is basically a way of just defining a certain kind of global object which you would instantiate. In other words, you'd have multiple copies of that same type of object, which has certain things in common, but then can have its own unique properties as well. And that's why I like to talk about, humans or people as a very good example of a class and an instance of a class. The thing is, we know certain information about humans, for example. Like we know that the average human is a certain height. Let's say we're talking about adult humans here. There's an average kind of range of height. Now, there are obviously exceptions, and each person is not identical in height. They have varying height, but there is an average range. Also, we know that people have names, and we have, 2 arms and 2 legs. Now, again, there are always exceptions to these, but you have this kind of base template that a human follows, but then each instance can be created in a unique way based on that template. Okay, so that's really what we're talking about with classes. And to give you kind of a real-world example that you would use in Houdini, your nodes themselves are actually a class. So the who.node is a type, it's a class. And so when you're working with nodes, there are certain properties. Nodes have inputs and outputs. Nodes have a name. They have a list of parameters, they have a definition. These are all things that they all have, although some of them, there are exceptions to that. There are some nodes that don't have an input, only an output. Okay, so, but then the template is set up to have inputs and outputs, and then each node that doesn't have inputs just has that as an exception. Okay. So your nodes, your parameters, everything like that, your geometry itself, all of these are classes within Houdini. Okay. So what we're going to do is we're going to use this example with human, just because it's a very nice and easy to understand and very memorable example. And what it should do is help you understand what a class is. So let's start. So I've got my Python source editor open here, and I've opened it very wide because we're going to do quite a bit of, with classes it can get a little bit complicated, so I just want to make sure we've got plenty of space. And then I've just got one Python shell open here, but I've expanded it all the way to the bottom so we can print and see what we're doing. Now what we're going to do is we're going to start by defining a class. Right, so let's start really simple. Now, to define a class, similar to how def was the way that we defined a function, a user-defined function. Well, typing the word class lets us define a class. And then we give it a name. Okay, we give our class a name, and then it also has round brackets to define this as an object. Okay. Now, it is not mandatory, but it is kind of common practice in Python that your classes begin with capital letters, where your functions all have lowercase letters. Okay. And later on, when we're using PyCharm, you'll find that there is an actual sort of inbuilt system where it makes suggestions to you, very similar to when you're in, I don't know, Word or Google Documents, where as you're typing, it may make, when there's errors, actual spelling mistakes, it'll warn you. But then when there's also just grammatical errors where it's suggesting that you do something a different way, well, PyCharm works similar, and it will always suggest to you, if you try and name your class with a lowercase letter, it tries to suggest to you, hey, I think you mean, human with a capital H, because it knows that classes are normally have a capital letter. Okay. So just keep that in mind. So if you see things with a capital letter, it's not guaranteed that it is a class, because maybe the person who coded it broke the rules. But if you stick to the rules and then go back to your own code later on, then it stands out when you see a capital letter. It shows you that that is a class versus a function. Okay. So we define a class like this, but with no arguments here. Okay, so we do not feed it arguments. We are able to give certain arguments to initiate an instance of a class, but those are done a little bit differently. So you do not put in any arguments in here. Okay. Now, for now, I'm just going to enter the word pass. Okay, so we're going to give no additional information inside of here, but without the pass, it will not count as a full block of code. So for now, we can just pass it. Okay. So there we are. I have created the class human, right? And now when I apply, nothing happens. Very similar to the function. We've created the actual class, but we haven't instantiated it. We haven't done anything with this, right? So now we can actually create an instance of a human. So in other words, and this is why I use human as an example, because it's very easy to understand that human as a word, as a sort of term, has certain connotations and certain information. If I have to imagine, or say to you, okay, well, imagine a human, or ask you information about humans in general, you're talking about the class. Whereas if I say to you, tell me about yourself, or tell me about your friend, that's a human, one copy of a human with their own unique sort of properties based on the general class of human. So how do we create an actual human from our class? So all we do is we call the class and use round brackets, because when you use round brackets, you're actually calling the class itself, right? If we just use human, this is now we're referring to the class. Okay, so for example, if we had to say x equals human, what we're doing is we're now setting x to be a copy of the class human, of the template, not a specific single human. Whereas if we put the round brackets, we're now instantiating that, so now x is a human. Okay, so we can set x to be equal to a human, and then when we print x, then you'll see what we get. Okay. Now what we get here, you see it prints with these triangular braces, which, remember I said, it shows us that this is an object, okay? And it's essentially telling us that it's an instance of the human class, and it gives it a unique kind of serial number so that we know if we've created another instance of a human, and we're referring to it, are we referring to the same human or a different human, all right? Now this way that it represents this is just automatic, because we haven't told it how to represent our own class. So it's going to make a few assumptions for us. Okay, so it fills in this representation. Later what we're going to do is replace this with something else that's a little bit more easier to read. Okay. So here we're able to define the class and then also create an instance of that class. Okay. Now, let's talk about properties. So before we get into the real nitty-gritty of it, the easiest thing to do inside of a class is define a property. So that's just basically a variable. So let me, inside of here, just in human, I'm going to just call it myval, and I'm going to say that it equals 10. Okay. So now when I create an instance of a human, every human that is created will have a myval value of 10. Okay. So that this property has a value of 10 in every human that is created. So if I now say x equals human and then print x, still the exact same thing is going to happen because I'm printing the entire human. But now instead of doing that, if I say I print x dot myval, now this is how I call a property within the class. You see that in Python, whenever we do dot, it's basically saying from this object, we're now calling something within that object. So whether it's a function inside of this class, or a property inside of it, or anything that can operate on this object. Okay, so we're saying go inside of human and grab the myval property. Okay, so if I print that, it's going to print 10. Okay, because myval is equal to 10. And even when I create another human, so y equals human, right? And then I print y.myval, it's also going to equal 10. But if I print y itself, you'll see that here it has a different serial number to this. Okay, so we know that these are two different humans, but they both happen to have the myval value of 10. Okay, and that's because we haven't given it we haven't made it different, made them unique. Now we can overwrite properties. So once we've created the human and called it x, so just stored it as x, right? We can now say that x.myval equals, and now we can actually overwrite that value. Okay, so now when we say y.myval, that's going to still print 10 because we haven't overwritten it in y, so y is still taking it from here. But if we say x.myval, it now equals 5. Okay, so the variable inside of this instance of human has been changed, even though the class of human has not been changed. So this is almost like the default value, but if we overwrite it, then it will keep that overwritten value. Okay, so this is how we work with properties. Now, let's move on to talking about how we initialize a class with some arguments, because when we define a human, well, we want to kind of actually give it a little bit of information. You know, when I create this human, I want to at least give it a name, okay? And also I want to say what age this person is, okay? Because maybe I'll make certain calls in here based on the information given when I instantiate this, okay? So this is what I want to be able to feed it. Now, instead of giving it the arguments here, we are going to define something inside of this class called a magic method, okay? Now, magic methods are very easy to spot. They always have a double underscore on either side of the name. So underscore underscore init underscore underscore. Okay, this is the function that we are going to be defining inside of here, and it's because it's in a function inside of a class, it's called a method, but these are magic methods because these are called by other sort of callbacks in Python, depending on what it is. For example, the init function, which stands for initialized or an initialization, right? So when this class is initialized, which means created, it will run whatever is inside of this function. The same way as I've spoken before about how we can add two strings together, but we can't multiply one string by another, and that's because the add magic method, okay, has been defined with strings, but multiply has not been, because how do you multiply two strings? That doesn't make sense. But of course you can add two strings together, right? So I'm going to go through a few magic methods that help you, but and there are loads more. I'm only going to go through a few, but you can always Google them and go through in detail and find which ones you need, because you only want to use the ones that are actually useful to you. So let's define our init function, our method, magic method. So it is a function, so we are going to use def. So we're going to define this magic method. The name is underscore underscore init underscore underscore. Now you have to stick to this naming convention, because this is only going to be called, like this will be called when we instantiate this this class. So if you name it something different, then it will just be an actual class method, and you can call it manually, but it will not be called automatically when you create an instance of this class. And then because it is a method, and it is callable, we need to give it the brackets as well. Okay. Now we are going to put some stuff in that brackets now, but I'm just going to show you here. So inside of this function, we obviously put colons so that we tab in, and now we're going to write a block of code that has to do with this. Now, the first argument, this is very important to understand. The first argument of every so not just the magic methods, the methods. So every class function is going to be a reference to the self. Now, this can be a little bit confusing, but just try to follow. Essentially, self is the first argument here. And what self is a variable that stores a reference to the instance of the object. So when we say x equals and then we run human, so we say human and then in brackets we are running this class. What we're saying is create a copy of this. Now, as it creates that copy, a reference to this copy gets stored as self, because this function hasn't finished running yet, so we haven't stored it in x yet. Once it has run, we will store that in x, but while it is busy creating this instance, we need a way to reference itself. So it automatically creates a variable and fills it into the first variable that we give it in any of these methods. Now, I've spoken in previous lessons about using certain conventions because it makes sense. You can, if you want to, give this a different name. You can call this whatever you want. Okay? And it will then, inside of this function, if you call this, so whatever, then it will call the reference to the instance of the class. But it's much better to just stick to the convention, because we know what self is, and when you glance at it straight away, you know that is referencing the self. If you start giving this custom variable names, then it gets very confusing. So unless you have a reason to do it, please rather don't. Okay? So just know that we have to reference self in here, in the init function. And it will be the same for every function that we define inside of the class. Is the first argument will always be self. Okay? And now we give it whatever arguments we want. Okay? Now these arguments that we give it here are what arguments are required when this class is initialized. So here we are initializing the class, or an instance of the class, and we're wanting to feed it some arguments. So these arguments go here. Okay, so it would be name and age. All right. So now inside of our init function, what do? Well, we want to define some properties of this human, and we want to define those based on the information we've been given. Okay. So what we can do is say, essentially we want to store a variable inside this class. Okay, the same way we did with myval. So a property, we just want to say name equals, and we want to set that name to be equal to whatever the user has given it. So we say name equals name. But this is not going to do anything, because we need to actually reference the instance of this class. Okay, we're not storing it inside the class itself, we're storing it inside the instance. And that's what this self is for. So we want to say self.name, because otherwise it's going to store this name in the class, and therefore every human will be called Jimmy, and that is not correct. We want to say that this human is called Jimmy, and then others may have their own unique name. So self.name means it goes to this copy of the human. Inside of it creates a property called name and gives it the name which is coming from the first argument, because I know the first argument is self, but this self is filled in by the actual function of running this class. Self is a reference to this class. So we do not have to give the first argument here. This is actually technically the second argument, which is here. Okay. So I know this is where it gets confusing, is the fact that it's kind of invisible. It's sitting over here. It's when we call this function, self is already filled in. Which is why a lot of people get very confused by, like, why is this self here but then it's not here, like, you know. But I hope this is making sense to you. Okay, so now we're going to do the same thing. We're going to say self.age equals age. Okay, and then we could do other things. We could create something else. You know, we could do self.myval equals and then give it something or whatever. But let's just stick to these two for now. Right, so you can do anything you want. You don't only have to create properties in here. You could do whatever. You could even run other external functions or import modules or do whatever you want. Okay, this is a function. So this block of code will run while it is busy creating this instance of a human. Okay, so it's going to run this and then it's going to store it in here. Okay, so now when we say apply, now obviously nothing's happening because I'm not printing anything, but I am technically creating a human, which I am calling X. So that's even though our human's name is Jimmy, I'm giving him an alias. So basically that's what a variable is. It's like an alias. So I'm saying, hey, person X, and he goes, yeah, actually my name's Jimmy and I'm 22 years old, right? So we can say print X, and X is still going to print like this because we haven't told it how to represent better. But if we say x.name, so we're asking X, hey, what's your name? Then it's going to say, hey, well, my name's Jimmy. Okay. Or we can say, X, what is your age? And it says, I'm 22. Okay. So now when we create another instance of a human, so we can say y equals human. And we will go and create Sally, right? And Sally is maybe 27. Okay, so we say now we created two humans, and let's say in here we still had our myval equals 10. Okay, so now if we go and print y.name and x.name, you'll see that it prints Jimmy and then Sally's, because we're asking X what their name is and then Y what their name is. However, and those are two unique values. However, if we still print myval, you'll see that it's the same for both of them because nothing has made those two numbers unique. Okay. Right. So that's how we define our init function. Now let's talk about some other magic methods that we can do just to kind of get a better sense of what this is doing and how to work with these. Okay, so one of the things that I've noticed here, you'll see that every time we print this human, just the entire object itself, it is represented in a very sort of unintuitive way. It's basically just saying, oh, it's a human instance. It's from this Houdini session, so it's this script, and it's the human class, and it's saying it's an instance, and then it gives the unique ID. So that's all great for a computer, but that's not really easy to understand. So why don't we create we're going to define the way that this object is represented. Okay, the object will still function the same, but when we say print and we print an object, like here we print X and we print Y, it doesn't know how to print something that is an actual sort of a broader concept. You know, it's like if I had to say to you, draw a human, but not draw a specific human, just draw the idea of humans. it's an abstract concept. You can't draw humans, you can just draw a human. Okay, you can draw many instances of them, but you can't draw the idea of a human. So that's kind of why that same existential crisis is what Python is having right now. It's saying, well, I don't know how to tell you what this instance is. It's got so many properties. It's got a name, it's got an age, it's got so much to it. So I'm just going to kind of feedback this. So what we get to do here is we get to define how it prints this value whenever we reference an object that is a human instance. And how we do that is with a magic method called repr. Okay, so in other words, this is how this is represented. Okay, and again, in this magic method, the first argument is going to be self. Okay, but we are not going to give it any other arguments, because when we print, we don't print this and then give it a bunch of arguments. We just say print x. So we have no other arguments other than self. Right? Now, in here, what we want to do is actually get this to print a certain sentence that we're going to give it. So, so print a string that is actually more representative of how we would like this object to be represented. But because the print function is happening outside of here, we don't want to, in this repr function, we don't want to print anything. We just want to return a value, because then when we do print this x is going to run this function, return a value, and that value is going to be printed. Okay, so essentially what we're wanting to do is return a string from this function. But what string do we want to return? So we're going to fill in a string that makes a little more sense for a human. Maybe something like, I am a human named, and then we wanted to have a name. But remember, we've had this problem before where, if we want to feed in a variable, we need to use formatting. So I'm going to insert the name here, so the person's name, and then I'm going to say, and I am, and then I'm going to insert their age, years old. Okay. So I say dot format, and now we're just going to replace name and age. But these are keyworded, which we didn't have to do. We could just put 0 and 1, but when it's something a bit more complex, like a sentence like this, I prefer to put in a keyword, because when I read this, I now know, just from reading this without having to figure out where the variables are coming from, I know what these are going to be. I'm saying, oh, okay, I'm going to grab the age here, I'm going to grab the name here. Cool, makes sense. So name equals, and then we need to feed it the name. But remember that this name is only defined on the instance of the object, not the human class. Humans don't have a name, but an individual human has a name. So we need to call this instance and grab its name. In other words, self.name, okay? Not just name, right? Because name is a variable that has not been defined. It only exists inside of this function, and it gets stored inside of self.name, right? So here, if we called name, it would complain saying, I don't have that variable. But self.name does exist, okay? So we're going to give name equals self.name, and we're going to give age equals self.age. All right, so that's going to now go and insert those two values, and it's going to return that value whenever it is being printed or represented in some form. Okay, and then when we print x and y, it's going to grab that value and then print it. Okay, so now when I print, you'll see that both Jimmy and Sally print their own little sentence telling you about themselves. Okay, now the one thing I like about this though is that we have actual triangular brackets, which tells us that this is an object. That this is not a string that we can actually manipulate and use, that this object itself is not just a string, okay? Because I could have a string with this sentence stored in it, and I could print X, and then it would print that whole sentence. But it's very different whether this is an actual representation of an object or whether it is an actual string itself. So I like to always do the same, stick to the same convention and include the triangular brackets, so that when we print this, it is still obvious to us at a glance that Okay, this is a much more human readable sentence. This is now something I know. I know the class, I know the name of the object, and I know the age of the object. But I know that it is an object and not just a string. Okay, so that's how we create the representation function. Okay, so let's move on to another example. We're going to just do one more example of a magic method, something that we have mentioned before. So I want to show you how to do this one to clarify, because this will start helping you understand how adding different data types together help. Like, you know, how some of them can be added and some of them cannot. The same way that I said that strings can be added, but they can't be multiplied. Well, now I'm going to show you how we do that with a human. So let's first try that. So we've created x and y. Well, let's print x plus y, right? Let's add these two together, okay? And when we hit apply, look at what happens. It errors out, okay? And it's saying unsupported operand types for plus, okay? And it's got an instance and an instance. So what this means, and I want you guys over time, that's why I always read these errors for you and try and explain what they mean, because eventually, and we're going to talk about it probably in the next lesson or so, is about how to dissect errors. Because you are always going to hit errors as you're coding, and you need to be able to, it's basically Python helping you. So what it's saying is, I have two instances, an instance and an instance, and you're telling me to add them with a plus. And Python's saying, this is an unsupported operand type, okay? So I don't know how to add two instances. That's what Python is saying here. So we can come in and say, don't worry, Python, I'm going to teach you how to add these two together, and then you can add them, okay? Now this magic method called add is called whenever there is a plus sign, because again, how do you add two humans together? Okay, it's an abstract concept, you know, like, because like it could be, you know, it could make another instance of a very small human that's whose age is 0, or it could be, you could be forming a group. Okay, so maybe you want to actually, when you add x plus y, what you want to do is return a list that is a group of these two humans together. Okay, so they've formed some kind of group or bond, or they've become a single entity, right? So like a couple. So let's do it that way around. So we define, and then the magic method is called add. Okay. Now add is a little bit special. The first argument is self, but it also has a second special argument, which is other. And other is obviously a reference to the second instance in this list. Okay, so we say x plus y. X is self, but other is y. Okay. Now I know that x plus y is the same as y plus x in most cases, well, like in floats and integers, but it's not the same in something like a string. It's also not the same when it comes to other operands like minus. If this was minus, then x minus y is not the same as y minus x. So it cannot assume that both of them are just going to be added together. We have to actually have a reference to one and the other, and then teach it how to combine these two. All right, so that's what we're going to do in here. So and we're going to do actually two different methods here of adding, and depending on what the second type is, because you see here we're trying to add one instance of a human to another. But what if we were trying to add something else to a human? Now, how does that work? So we are going to tackle both, but let's just start with the simplest one and say, okay, two humans together, right? So we're going to say, what we want to do is create a list, okay? So now I have mentioned before that when we're creating functions and we're spitting out lists, it is generally better practice to return tuples instead of lists, because you don't want lists to be able to be altered. You want to return a tuple, which is kind of like packaging something in a sealed way, and then you're expecting your user to unpackage it and work with that. Even if they want to keep it as a list, they need to convert it to a list. So they kind of open the box. But we want to give them something sealed. So that is like using a tuple, right? So we want to give them a tuple, and all we want to do is give self and other in a list together, okay? Because we're essentially just saying, oh, if you want to add two humans together, we're going to create a group, okay? So we're now a list together. But how we remember, we're in a function here, so we need to return this value. So this list, this array, is what we want to return, okay? So now when I say print x plus y, it's going to print a tuple whose first index is an object, okay? But because it needs to represent this object, it runs the repr function and prints this long string. But this is not just a string, it's actually a reference to this object, okay? So we say it's got our Jimmy as number 1 and our Sally is number 2 in this list, okay? Because we've said x plus y. And if we went the other way around, it would be the other way around. Y plus x would then give the list the other way around. And to show you that these are still actually objects and not just strings printed by the repr function, if we add these two together, so we say z equals y plus x, and then we go, we're going to print z, so printing z will print that list, but instead we grab the first object in that list, which is 0, so that should be Sally, right? But you see it's got this whole string. If we now go Sally dot age, it's going to print 27, because this here is just a string representation of this object. Really, it is an actual object that still has all of its properties, all of its functions attached to it, everything. This is an actual human. Okay, so that's just proof over there of how this is all working. Now, this is all fine and well and very, very simple if we're just adding two humans together. But what if I now say y plus 2, okay? And then I say print z, okay? Now, what it's doing is taking 2, the second thing in the list, and just creating a list out of this with Sally and the number 2. And that's not what we want, okay? So what I'd like to do in this case, and we can obviously do whatever we want with this, but if the user tries to add something that shouldn't be added, you can always return errors as well. So you could even say add, and then you do a try except and look for certain errors, or do check for whatever type they've tried to add, and then you can spit out an error saying to them, hey, you can't add numbers to a human. This doesn't make sense. But in this case, what I would like to do is actually, if they give us a float or a string, a float or an integer, so a number, then I would like to add that to their age. Okay, so let's do it that way around. Now, the first thing we're going to do, adding it to their age is going to be really, really simple. But the first more complicated thing to do is check whether or not what we're getting in other is actually an instance of a human, or is it an instance of a float or an integer? And that is something that we haven't covered yet. So there is a function that helps us do this, and that is called isInstance. Okay, so isInstance is going to check, so here it returns whether an object is an instance of a class or a subclass thereof. Okay, so the first thing that we feed it is the object that we're assessing. The second thing we feed it is the class or type or tuple, which is basically essentially saying, is this one of those other things? Okay, so is A an instance of B? Okay, so in this case, what we're doing is we're checking other, because we know that self is self, as in when we say y plus, we know that y is an instance of a human, because if we said 2 plus y, then it wouldn't be running the y add magic method. It would be the human add magic method. It would be running the integer add magic method, because the plus operates on this object, not this one. Okay, it simply adds this object into this one. Okay, So we know that self is a human, but what we're assessing is other. So now we say other, but what we need to do is return and have a check whether other is a human. Now, how do we reference a class? Well, we refer to the class, so this is the class name, but without calling it. So if we say that, then it's going to create an instance of the class. It's going to create a new human being. But instead, if we just say human, then that means it's checking the entire class itself and saying, is this one of these? Okay, so this will then return true if it's a human. And what we're going to do is say if is instance other human, then return a tuple of self and other. Okay, so now if I do this and I've hit apply, instead of returning a tuple that has a human and a number, it returns none, because it gets into this add function, which is over here. It triggers the add, jumps inside, tries this returns false, so it fails, doesn't do this, so it returns nothing. Okay, so what we're going to do now is say elif. So if it's not a human, then what is it? So we need to give it another, remember with elifs you still have to give it another thing to compare, something to check. Okay, so I can't think of the word right now. So we say is instance, and then we give it other again, because we're still checking other, but we're saying, well, is other an integer now? Okay, and how we'd give an integer is we just say int. Okay, because int is an actual object type, so we just say is other an int. But also, if it is a float, we want to be able to just add the same thing. Okay, it doesn't matter, right? So we're going to now say or is instance other float, because float is another object type as well. So we're essentially saying, is it a human? If so, create a group. If it's not a human, then if it's an integer or it's a float, then do the following. And what we're going to do here is we're just going to, okay, so that, well, there's a couple of things we can do. One is that we can alter the age of the actual human. Okay, so when we say y plus 2, we're going to age y, so we're going to age Sally by 2, right? So let's show you that method. Now how we do that, remember we're wanting to alter the actual age of the instance of the object, okay, of y, and we're running this in y, so self is y. So we say self dot age, because we want to say change the age of that, so the age property of y by, and then by other. Okay, so plus equals other. So whatever we feed in as other is going to now be added to the age. Okay, but let's have a look at what happens now. If I hit apply, right, this still returns none. But if I had to print, so I'm going to leave the print z over here, but if I say print y, now you'll see that Sally claims to be 29 years old. Okay, so Sally has aged 2 years, but what gets returned is none. And, well, what gets printed here in z is none. And that's because we're setting z to be equal to y plus 2. But this add function is not returning anything. It is acting in place. Remember, I spoke ages ago, right in the beginning of this course, about functions that act in place. So some things return values and others just do something. They change something, but they don't actually return an answer. They don't return a value. Okay? So, you know, it's kind of the same as asking someone to go and fetch something for you. Oh, please, could you go and fetch my cell phone for me? Then they go away, get it, bring it back, and hand it to you. That's returning a value. But if you just say to someone, oh, could you go put on the kettle for a cup of tea? They go and put on the kettle. They don't bring you the kettle. They just go and put it on. They did something, but they didn't return a value. Okay. So we need to be careful about whether this is what we want. Now, sometimes this is going to be what we want, but then saying z equals y plus 2, that doesn't make sense then. We're just going to say, well, y plus 2, okay? And then it's just going to alter y, okay? But we need to be very careful with this type of stuff. In-place things are sometimes a little dangerous, because what if you want to you want the young version of Sally and the old version. You're sort of wanting to maybe compare the two of them, or do something with them. Now, if you just go and say y plus 2, it's altering the original, so it's overriding the original, and that is not always advised. Okay, so this is one way we can do it, but I'm going to comment this out. So with a hash, you can just comment this line out, so it'll have no effect. And I'm going to do a different method here of altering the age, right? And this is that we're going to want to return a value so that it can be stored in Z. But what I want to return is an instance of a new human being, okay? Except that human has the same properties as Sally, so the same name, right? But has a greater age. So what we can do is we can instantiate a new human being, but we can give it the same, so we can say self.name, right? So, because remember, when we're creating a new human being, we need to feed it a name and an age, but we already have a name, okay? Y has a name, so let's refer to our own name. We say self.name, and then we give it self.age, but this is where we're going to go a little bit different, is we're now going to add other, because other is this value that we're wanting to add. So we're taking the age that Sally was, but we're adding our other, and then creating a new human being with these properties and returning that value. So now when I print Z and I print Y, okay, let's just hit enter here a few times so that they're separate. And now you'll see that I have Z is equal to a human called Sally, who's 29 years old, but Y is left unaltered as a human named Sally that is 27 years old. Okay, so this is how we kind of define how things get added or subtracted or divided. So there is a different magic method for each of those if you want things to be able to be divided. So if you say one human divided by another, or if you say Jimmy divided by 2, what do you want to happen when you try and divide Jimmy by 2? Do you want him to die? Because that's what happens when you divide humans, So if you don't define it, Python doesn't know how to operate on these two different classes, two different objects, unless you tell it what to do. Then that includes objects that it does know how to add, but with objects that it doesn't know. Okay, so it knows how to add 2 to another integer, but it doesn't know how to add 2 to y. And of course, if you try to go 2 plus y, it's going to complain, because that's running not our own internal add magic method, but it's actually running the magic method of an integer, and there is nothing inside of an integer that defines how it can be added to an object, to a human. So that's why we have to do it this way around. It must be y plus 2 and not 2 plus y. Okay. All right, so this has been quite a long video already, so I'm going to stop it here. But then I'm going to, we're going to have a part 2 of classes where we're going to continue from this exact same point. So you can even keep your scene exactly as it is if you've been following along, and we're going to jump back into exactly how it is. But I just want to split up the video for you so that it's a little bit easier to watch and to manage. All right, so I'll see you guys in the next lesson.